Hi everyone, good evening. We are Group 76 and I'm Raj Patel. Today we'll be presenting our final project for the Neural Networks and Deep Learning course titled AI in Academia, Forecasting Student Dropout Risk and Academic Success. Now this project uses machine learning models to help predict which students are likely to drop out and which are likely to succeed, a challenge that has important implications for educational institutions. Now, currently in the US, the college dropout rate is around 29.2%, meaning nearly one in three students don't complete their degree. And dropouts often face reduced income, fewer job opportunities, and greater social inequality. Now, student success is affected by multiple complex factors, of course, such as financial background, prior education, family, and many more. Our goal here is to use data-driven AI techniques to identify at-risk students earlier, enabling schools to intervene and support them effectively. Now let's talk about data description. We used two data sources. One is Kaggle and the second one is the UCI ML repository. Both had identical structure and content with 4,424 entries and, to be precise, 37 features. The dataset included academic, demographic, and socioeconomic data, plus performance in the first two semesters. The the original target had three classes. The first one was enroll, second one was dropout, and the third one was graduate. Now, what we did here is we simplified this to a binary classification problem. One is dropout versus not dropout. Importantly, the dataset had no missing values, and we used label encoding, normalization, and SMART to address basically class imbalance. Ah, Now EDA. So our exploratory data analysis confirmed a first few important points. First is the class distribution was imbalanced with 1,421 dropouts and 3,001 not dropouts. Now, features like GDP, nationality, inflation, and unemployment showed little correlation to the target and were removed. So, SMART was applied to balance the classes, making our model more robust during training part. Now let's talk about the baseline model. For our baseline models, we tested several traditional classifiers such as KNN, logistics, logistic regression, random forest, boosting, and SVM. So initial performance ranged from 85% to 91% accuracy, out of which, KNN achieved 85% after tuning, and the random forest reached up to 91% of accuracy. These models gave us a solid benchmark to improve upon using ensemble and neural network approaches. Now, let's talk about model optimization. After the baseline model, we then used a grid search CV for hyperparameter tuning and evaluated all models using metrics like accuracy, precision, recall, F1 score, and ROC AUC curves. Now, feature importance was also analyzed to better interpret how each input variables contributed to the prediction. And the step helped us optimize not just performance, but also explainability. A key factor for use in educational environment. Now, if we talk about neural network and ensemble models, so we explored advanced ensemble models and neural networks, including random forest, hypertune, XGBoost, MLP, bagging, and stacking classifiers. And among these, random forest and XGBoost performed the best, and like both achieving an accuracy and F1 score of 92%. And these models were not only accurate but also more stable and interpretable than the MLP or DABUS. Now let's talk about the best model. Of course, our final best model was the hypertuned random forest, which achieved 92% in both accuracy and F1 score. It performed consistently well across all metrics and was less prone to overfitting. Moreover, it provided feature importance values that made the result explainable to non-technical stakeholders like university counselor or policymakers. Now, references. So our dataset sources include Kaggle and the UCI machine learning repository. Both datasets offered reliable and well-structured data, crucial for the supervised learning task. So in conclusion, our system demonstrated how machine learning can assist universities in identifying students at risk of dropping out with accurate predictions and interpretable models. Schools can now, basically deploy proactive support strategies and improve student success rate. That was it. Thank you very much for listening to the entire presentation. We are happy to take any questions if you have any. Thank you.